Hi there, welcome to another college math video. In this video, we're going to start to look at Venn diagrams, which are the visual representation of dealing with sets. So here are our objectives for this video. We're going to look at the properties of set operations, describe complements, intersections, and unions, and then use a Venn diagram. When you think back on sets, this is probably the video that you're going to remember the type of stuff you're going to remember dealing with the most. And it's nice because there's a lot of visuals here. Okay, so to prepare us for starting to look at the visuals, there's a couple things we have to keep in mind. The note here on this slide is to keep in mind the differentiation between the words and or. So when we think of those words in the English language, they're usually a word that you breeze by pretty quickly, not something you spend a lot of time with, but in sets, it's important to keep in mind the differentiation between the two. So it's very different to say, I want a car with air conditioning and heat versus I want a car with air conditioning or heat. If you say and, a car with air conditioning and heat, it means you are only willing to accept the car that has both. If you say I want a car with air conditioning or heat, it means you would be happy with the car that had air conditioning, happy with the car that had heat, and you would also definitely accept the car that had both of them. The word or sometimes has, in the real world, there's both meanings. Sometimes it means exclusively one or the other. But when we're talking in the realm of sets, if we see the word or, we're assuming it's in this context where it could be one, the other, or both. You would happily take the car with just air conditioning, the car with just heat, or the car that had both of them, if the word connecting them is the word or in sets. So keep that differentiation in mind as we start to see some of these ideas. Okay, so let's start some notes. So we're going to use this information to fill in our notes here. The 4 most popular pets in Japan as of October 2016 are dogs, cats, fish, and turtles. So let's say with that information, we define the universe to be all people in Japan. Remember, if we set the universe, this just kind of defines who it is we're talking about or what it is we're talking about. It limits us to a certain set of items instead of having everything that exists in the universe as part of it. So our universe is the people in Japan. We'll have set A be people that own a turtle and set B people that own a cat. All right, so the visual representation of the universal set. We'll typically draw the universe in the shape of a rectangle. This is how you'll typically see it drawn. And we'll have a U up top just to indicate that it's the universe. You don't really have to draw that U there. And it technically could be a different shape, but this is what I'm going to stick with. So everything is contained inside the universe that is the people in Japan. So right now, here are all the people in Japan. We don't necessarily know anything about them. That's all we care about is that the universe contains the people in Japan. So if the question we're asking you, if you have this visual representation, and the question asks you to identify all the items in the universe, you would give every element that's listed inside this picture, the visual image. All right, this sets us up to go to the next piece, which is then having a set in the universe. So let's, for our purposes, let's say we're putting set A inside of this set, which is people that have a turtle. So we still have the universe. And now inside of the universe, we still have all the people in Japan. We'll have set A exist inside this universe, and set A is all the people that have a turtle. So you can sort of picture that universe still contains all the people of Japan. We're just now able to kind of partition them. If you're a person in Japan that has a turtle, then you are inside of set A, and if you don't, then you're outside of set A. But the universe still contains all people. So if we were looking for elements from set A, we would pull all the elements that are inside of the circle, which leads us to the first of the 3 that we're going to look at today, which is the complement. So the definition for a complement is the set of elements in the universe that are not in set A. Not is the important word here. And I'm using set A because that's the example we're using here. But it could be for any set that you're talking about. Symbolically, it would look like this. So if we're talking about a complement specifically, they'll just be, it looks like an exponent, but it's not. It's just a little tick mark that's up there. It's not a number, it's just a little tick mark. So this is what it would look like symbolically. This signifies a complement, meaning the elements that are in the universe but not in set A. And in this case, if we've defined A to be people that have a turtle, then a complement, which is basically the opposite, is people that don't have a turtle. So a complement in our case people that don't have a turtle. And so visually, if we were looking for all of the elements that are in a complement, here's our universe, and here is our set A inside that universe. If A is what's inside the circle, then a complement is everything outside of the circle. This is just a visual shading to give you an idea of where you would pull the elements from. Typically, the universe will already have all of the items listed inside of it, and then if I'm asking you for a complement, then you would just list all the items that fall outside of the circle. So the complement, you can think of it as being not, so there's A and then there's not A, or you can think of it as the opposite. Two different ways to think of the complement, all meaning the same thing, essentially the set of elements that are not inside the set, whatever set that would be you're talking about. All right, so we have the universe, which is the whole rectangle. Then there's a set inside the universe, and the complement is still inside the universe, but it's just stuff that's outside of that individual set. And then we start looking at when there's more than one set in the picture. So we have intersection and union. Symbolically, intersection looks like this. We have a down symbol for intersection. There's no line underneath it. It's just showing you that that's the symbol we're talking about. And so this is when there's two circles inside of the universe. We've already defined our sets A and B. Set A is people with a turtle, set B, people with a cat. So an intersection in general is the set that contains all the elements that are common to set A and B. So let me give you the visual of this. If this is our universe, still the same universe containing all the people in Japan. We have set A, which are the people that own a turtle. Set B, people that own a cat. And if we're looking at the intersection, it is where the two sets intersect, the set that contains all the elements that are common to both. If we're looking for the intersection, then we are looking for the elements that fall in their overlap, items that are common to both of them. So in our scenario, this would be people that own a turtle and a cat. And so you'll notice the word and is in this definition. This is going back to the idea that it's different to say and versus or. So in this case, we're using and. The word and goes with the down symbol, goes with the intersection. All three of these things convey the same message. Compared to the union, which is the symbol to pull these two together is a U. Simply a U, helpful. U for union. And this is the set that contains all elements that are members of set A or set B. So one more time, the set that contains all elements that are members of set A or set B. So you'll notice in this one, inside the definition, we have the word or here, or the U and the union. All three of these convey the same message. And so visually, we still have the universe, which contains all the people of Japan. We still have the set A that has all people that have a turtle. Set B, all people that have a cat. And if we're looking for the union is the marriage of the two. When you get married, you don't just bring what you have in common, like the intersection. The intersection's like when you're dating, you talk about what you have in common. When you get married, everything comes to the picture. Everything person A has, everything person B has, and certainly everything that they both have. So for our example, this set would contain all the elements or all the people in Japan that have either a turtle or a cat, or certainly both of them. We just usually don't also say the end part. We would just say that all the people that have a turtle or a cat, and certainly it would include both. So you can kind of get the visual representation from this also of the scenario with the car with heat and air conditioning. So if we have A has all the cars that have air conditioning and B is all the cars with heat. If I say I want a car with heat and air conditioning, I'm only going to look at the cars in the overlap, the ones that have both. And if I say or, a car with air conditioning or heat, then I would certainly take the ones that just had air conditioning, just had heat, and I would happily take the ones that had both. So these are the three that we're going to see throughout this video. The complement, which is the opposite, the intersection, which is their overlap, and the union, which is the marriage of the two, everything that both sets contain. So before we start to do some examples with these visualizations, there's just one more thing I want to talk about. When I drew two sets, I drew them specifically having this one unique overlap. So if there are two sets in the universe, there are actually 4 different possibilities on how they can interact. So I want to draw them out and just kind of go over why I draw it the way that I draw it. Think about it for a second. Imagine, I'll kind of set this up for you. 4 different scenarios. If there are 2 circles that have to go inside each of these, 4 different ways they could interact together. Think about it, see if you can figure out what might go in there. And then let's see if we're on the same page. So one way is definitely the way that I've already drawn them with the one specific overlap, and these are called overlapping sets. But it's not the only way that the 2 circles could interact. The 2 circles could also not interact at all. They could have nothing in common. Sure, we can label them A, B. It doesn't really matter. Inside the universe, if this scenario were people in Japan, we could have people that have the same that we set it up, people that have a turtle, people that have a cat. If there aren't any people that have both, then those 2 things would never interact. And these 2 would specifically be called disjoint sets. So visually, this could have happened. It's pretty unlikely in our example that would happen, but the sets could have nothing in common. If I set it up to be all Valencia students and set A is Valencia students with a 4.0 GPA and set B is Valencia students with a 3.0 and below, those 2 sets aren't going to have anything in common. Those are totally different sets, disjoint. Okay, another way the 2 sets could interact, it could be that one set is fully contained inside the other. So maybe set A is all Valencia students with a 3.0 or above, and then set B is all Valencia students with a 4.0. Sometimes it's a more specific way to describe, but not necessarily always the case. And if this happens, these are called subsets. That's a visual image of one of the videos you've already seen. Some items being contained within another set, still all happening within the universe. And then the 4th one, which is probably the most difficult to come up with, is that the 2 sets are actually exactly the same. And we've seen that visually. We've seen it with the sets with their elements listed, but we haven't seen it visually. These would be called equal sets. Remember that definition earlier on, if the 2 sets have exactly the same elements, then they're equal sets. So visually, there wouldn't be any that fell in just A or just B. They would all be in the overlap. So these are the 4 different possibilities of ways that the two sets could interact with each other. And the reason that I draw overlapping sets as a default all the time is because this one visually takes care of all of these other possibilities. So for example, if we had two sets that were disjoint and we were filling in all of the elements, I would simply only have elements in this little piece of A right here and this little piece of B right here. There just wouldn't be any in the overlap. But visually, we still are able to place all the elements. If we had some sets in common and we tried to draw them as disjoint, then there wouldn't be a place for those elements to go and it wouldn't work out. So disjoint fits into overlapping. If we have subsets, if specifically we have the way that I've drawn it here, set A with set B inside of it and a smaller set, then I would have items in just A and then some in the overlap, but there wouldn't be anything in just B. So if we end up with two sets that one is actually a subset of the other, overlapping sets visually takes care of that. And then if the two sets contain exactly the same elements, if I fill them in through overlapping sets, I'm only going to be filling in items in the middle. There just won't be anything in only A or only B. So if I have equal sets, it'll work by drawing overlapping sets. But if you try to go with one of the other three, disjoint, equal, or subset, and you don't have that, then there are going to be elements that you're not able to place. So as a default, when there's two sets in the universe, you can just always go with overlapping sets as the way you draw it, and then maybe you'll notice some sort of special relationship from there. So that's why we'll stick with overlapping sets as the one we always draw. All right, so let's see some examples where we're actually placing elements inside here. So we're going to fill in the Venn diagram and then answer the questions. So the universe in this case is all elements such that X is a Disney theme park in Florida. And then set A inside of that universe has all the elements that have the word kingdom in it. So first we define the universe, and this one is presented in Set Builder, as you can see with this specific format, but it'll be easier for us to put it in the Venn diagram if we have every single element. So what does the universe actually contain? It contains Disney theme parks in Florida. So what are those? We'll go with just the main four. We have Magic Kingdom, Animal Kingdom, Epcot, and Hollywood Studios. This is just converting that set builder notation to roster form. And then we have set A, which is all elements that have the word kingdom in it. Now, if we hadn't defined the universe, set A would have to be every single thing that exists anywhere that has the word kingdom in it. But since we've defined the universe, we are only looking at the options that exist within the universe. So from the universe, set A is everything that has the word kingdom in it. So our options, Magic Kingdom, Animal Kingdom, Epcot, Hollywood Studios, that means set A contains Magic Kingdom, since it has the word kingdom in it, and Animal Kingdom. You might be wondering about water parks or other special things. We're just going with the four. All right, so we've set up what they look like in roster form so that we can actually fill them in the Venn diagram. Let's get the visual. Remember, the rectangle represents the universe. The universe contains all the elements. Everything in the list from the universe has to be contained there. And within that, we have one single set, in this case, A. If we had two, we would draw the two circles with the overlap, but we only have set A here. So we have to place all four of these elements from the universe. I'm going to suggest that you go through it from the universe. So the first item is Magic Kingdom. Where does Magic Kingdom go? Since Magic Kingdom is in set A, it will go inside the circle. So we'll fill this in, Magic Kingdom. Put a little check so we know we're done with it. Okay, second item from the universe is Animal Kingdom. Animal Kingdom has to be placed in the universe. Where does it get placed? It's either inside or outside of the circle, and since it is part of our list of A, it has the word kingdom in it. It'll go inside this circle. Next item in the universe is Epcot. Has to be placed in the universe, so it's got to go somewhere in the rectangle. Since it does not have the word kingdom in it, it'll go outside of A. And I chose to put it up in this corner. As long as it's outside of the circle, it can go anywhere outside of the circle in the universe. And then the last element of our universe is Hollywood Studios. Hollywood Studios is not in A, so it must be in the outside of A. Hollywood Studios. So that's the first part of this question. Fill in the Venn diagram. We've done it. There's your visual representation of this information, the universe with the set inside of it and all the elements listed there. Okay, then the question that goes along with this one is to find a complement. Now, it doesn't say what format to find it in. We're just going to go with roster because that's my preference. But you could use a different format if you wanted to. So a complement, remember it's A with this little symbol, this little tick mark up top. This symbolizes complement. Contains all the elements that fall outside of the circle. So inside the circle are these two, outside of the circle, everything out here. The elements there are Hollywood Studios and Epcot. You might be wondering if you could write them in a different order. Your thought first was to write Epcot and then Hollywood Studios. That's fine. Remember, the elements in a set can be in any order as long as they're all there, as long as you're using the right notation to indicate that there's a pattern or something like that. All right, so there's one example of filling in a Venn diagram and answering questions about it. So this was one with one set. Let's look at another one with two sets. So we have the universe containing the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have set A with 2, 3, 6, 8, and set B 1, 4, 6, 8, 9. So the directions are the same for this one. We're going to fill in the Venn diagram and then answer the questions. So let's draw the Venn diagram first. When you draw these circles, it's really tempting for whatever reason to draw a really small overlap, but it's actually a lot easier if you give yourself a big overlap because typically you have to fill in a bunch of items inside that location, potentially. So I think that's helpful. All right. So we have the universe that is the rectangle. Set A and B are sets inside that universe. There might be some elements they have in common, there might not be, but remember these overlapping sets takes into consideration all those possibilities. So then let's go ahead and fill in items from the universe. So let's go one at a time. The element 1. Look at these two lists. It looks like it is only in B, so the element 1 will go somewhere over here. As long as it's in this region, that's fine. It can be anywhere in that region. Done. The element 2 looks like it's only in set A. The element 3, we look through our list, looks like it's only in set A again. Fill that in there. The element 4 is only in B. The element 5 is not in A and not in B, so 5 must be outside of the sets. It's still in the universe. It has to be in the picture. The element 6 is in both of them, so 6 will go in the middle. The element 7, not in either, so 7 will also be on the outside. The element 8 is in both of them, so in the overlap here. The element 9 looks like it's just in B. And the element 10, not in either list, so again, we'll list it on the outside here. What's important is that these elements are in the correct region or the correct zone. So the 2 and the 3 should be in this piece right here. The 6 and the 8 should be in the overlap. 1, 4, 9 out here. And then 5, 10, 7, anywhere outside of the circle but still in the universe. Okay, so then we're going to answer the questions. So the first one is to find a complement. Let me give you a quick little visual of where we would pull this from. I don't want to draw on top of our picture. So remember, a complement simply means not A, the opposite of A. So if this is set A, then a complement is going to be everything outside specifically of A. So you really don't even care that B is drawn in the picture. All you're concerned with is that it's not A. So the shaded region is where we're pulling elements from. This is where we get a complement from. My choice is to write it in roster form, so I'm going to pull the elements that fall, again, here's A, outside of A. And you can list them in any order, so I'll just start down here. Looks like I have 5, 10, 7, and 1, 4, 9. If you chose to write those in numerical order, totally fine. If you wrote them 1, 4, 9, then 5, 7, 10, it doesn't matter as long as you have those elements there. The visual of here's A and then the complement is the outside of it. That's what's going to be helpful. The hardest part isn't really listing those elements, it's deciding where you're getting the elements from. If you can get this visualization of where they're coming from, it's just a matter of, listing those elements specifically. Okay, the next one is our down symbol. So this is an intersection. Remember, the intersection is what they have in common. So if these are the two sets A and B, A intersect B is going to come from their overlap in the middle right here. So in our picture, that's this zone right here. So it'll contain the elements 6 and 8. Opposite order is also fine. And then the last question for this picture is the union, A union B. Remember, union means everything from both. It's the two sets getting married. So it's going to be everything from both of them. So all elements that fall inside either circle. So we have 2, 3, 6, 8, 1, 4, 9. Now, long term, looking at a question like this, if you weren't also asked to draw the Venn diagram, if you were simply asked to answer these 3 questions, you don't have to draw the Venn diagram if you don't want to. If the question doesn't tell you to draw the Venn diagram, you can look from the universe and compare your specific set to come up with the answers. You could look at A and say, okay, it's everything that's in the universe that's not A, and then list 1, 4, 5, 7, 9, 10. You could come up with a list that way. For the intersection, you could look at A and B and say, what do they have in common? For the union, you could list everything from the two sets without double counting anything. So you wouldn't put 6 twice and you wouldn't put 8 twice. The Venn diagram doesn't have to be there, but it's a really helpful tool. It's the visualization of it. So even if it doesn't ask for it, for the most part, I would suggest drawing it until you're more comfortable. If it's me, I'm pretty much going to draw it every time. But for the videos, we'll just see what the question asks for and go from there. All right, so this is one example of looking at with two sets in the picture. All right, let's do this one as a practice. We've got the universe and the 2 sets inside of it, letters this time instead. And some of the questions are similar, but the last one's a little bit different. So I want you to give it a shot, pause the video, see if you can get the picture right, and then see if you can get all the questions right, and we'll compare notes when you're done. All right, so let's see if we're on the same page. So we have the universe, and all items from the universe have to be placed inside this picture. In this universe, we have set A and we have set B. We have to place all items from the universe inside here. So first A looks like it is in only A. Then B looks like it's in both, so in the overlap. C is in just A. D is in neither, so it'll go on the outside here. E, also in neither on the outside. F is in both. G is in only A. And H is in both. Okay, so we could have drawn this picture different. It just so happens that B is a subset of A, but this picture totally works and is fine. The mistake that I would most often see on a problem like this is students forgetting to put these items in the universe that are outside the set, the D and the E. And that's most often because people just look at A and B and try to place all the items. I would suggest that you go from the universe because every single item from the universe has to get placed. So as long as you go through that list, then you're guaranteed to put everything in the list. All right, so let's go through the questions then. A complement. I'll give you a quick visual of what that would look like. Remember, A complement is everything outside of A. So we want all the elements that fall inside that picture. So here's A, everything outside of it. In this case would simply be D and E. If we want B complement, We want everything outside of B. So here's B. We want to shade everything on the outside of it. We're looking for just the items that fall in this shaded region. So here's B, everything outside of it. In this case, we have A, C, G, D, E. The order of those elements does not matter. The next one is our intersection. So this is where they overlap, where they intersect. So it'll be right in the middle. The place they intersect contains B, F, and H. Then we have the union. The union is the marriage of the two sets, so everything inside both circles. This is just to give you the visual of where it would come from, so everything inside of here. So it contains A, C, G, B, F, H. And then the last one, potentially a little tricky, this is the complement of A intersect B. So this one requires a little bit more thought before you get to the answer. What's inside of the parentheses is A intersect B. So that's what this picture right here looks like. If we want the complement of that, then we want the opposite of the shading. The complement is always the opposite. So if A intersect B has this middle region shaded, then A intersect B complement is going to be everything outside of that middle region shaded. So it'll be all the elements that fall into this shaded region. So everything except the overlap, which in this case would be A, C, G, D, E. Now in this case it worked out to be the same as B complement, but that definitely is not always the case. That's just what worked out based on our picture. I'll try to give you these visuals whenever I can. I would suggest using the visuals to your advantage, but again, you don't have to. If this question didn't ask for the picture, but just asked you to identify or answer these 5 questions, it would be fine if you didn't draw the pictures. I think it's easier to do that, but it's up to you. All right. Let's look at another example. Oh, actually, we'll do this one as a practice problem. So this one has some information about the civilizations of Sparta and Athens. So you've got some information already kind of set up inside these Venn diagrams. So this is going backwards. Instead of starting with the universe in a specific format and going to the picture, we're coming from the picture and going back to one of our set formats, roster, set builder, or description. It's up to you, but let's go with roster for this question. So go ahead, pause the video, and then pull out what are the elements in the universe, what are the elements in set A. Set A is defined to be Sparta, and set B defined to be Athens. All right, so let's see if we're on the same page. If there's going to be a mistake, it's typically going to be in this first piece right here. Students often mistake or believe that the universe simply means everything outside of the circles, but it's not. The universe is everything inside the whole. There's not a rectangle drawn here, but it's everything inside the whole rectangle. That is the universe. So the universe contains all those elements. Women have basic military. I'm going to shorthand these. Government is an oligarchy. Strong military. Located in Greece. City-state. Women at home. And government democracy. The universe is everything that's in the picture, so every element that exists within that rectangle. Set A, everything that is just Sparta, contains everything that is only in the circle A. So this would be women have basic military training. The government is an oligarchy. Strong military. Located in Greece. And a city-state. Compared to set B, which is all the items for Athens, would contain these 4 elements. Located in Greece, city-state, women at home, and the government is a democracy. You can see hopefully that sets is a good way to compare things. This gives us the visual comparison between things. So this is something you could definitely use in your other classes. Anytime you're making comparisons between civilizations, between countries, between formats of some sort, any comparison lends itself to the visualization of making that comparison, filling in what does only one have, what does the other have, what do they have in common, and so on from there. So again, the only mistake I typically see here is that the universe contains all of these items, not just stuff that falls outside. And in this case, the colon listing Sparta just was telling you what set A can, like what is it, and set B Athens. Those weren't intended to be elements. So if you listed them, you don't have to list them. My intention wasn't that they're elements here. All right. So let's look at a couple more things before we finish this video off. I just want to go over being able to shade in and identify where your solution would come from a Venn diagram, because filling in the Venn diagram isn't as complicated. It's once you start to analyze and then pull things from the Venn diagram that it gets more complicated. And this video only looks at Venn diagrams with 2 sets. We will move on to 3 sets. It's not as complex with 2, but being able to see the ideas here with 2 is really helpful when we move forward. Okay, so we've seen this one before, a complement. And I'm going to draw these all to have the 2 sets. And then we'll shade where answers would come from. So in the first one, a complement simply means not A. So again, everything that is outside of A. There we go. Then we have B complement, which is everything outside of B. This could all be from one picture. I'm just giving you the different visuals of where you would pull elements from. Then the union, which we saw before. The union is the marriage of the 2. So that'll be everything inside both of them. Then we have the complement of the union. So we haven't seen this one. And if I had simply asked you to find the complement of the union, the reason we're doing this is so you can see sometimes you need kind of a progression. Sometimes you have to give yourself steps. So if we first identified what the union looked like, then we could easily identify what the complement would look like. It's the opposite of this picture on the left bottom here. So it would be everything outside of these pictures. And I'm definitely not drawing all the possibilities. There's more than this. I'm just trying to give you the tools to be able to figure it out on your own. So again, if I just asked you for A union B complement, I would first suggest you find what it is that is inside that parentheses and then simply find the opposite of it. And a couple more. What if we had A complement union B? So the union means that everything from both is going to be shaded. So this is my final answer. This will be my final answer. A, B. And I want to compare that to A complement intersect B. Because just because you see the symbol union or intersection, union doesn't just mean, oh, it's everything in the 2 circles. Intersection doesn't just mean, oh, it's the overlap. It's the idea that the union is everything from both ideas, and the intersection is only where the 2 ideas overlap. So let me individually draw these 2 ideas. We have A complement, as you've seen, and then simply B. So those are the 2 things that are being pulled together. In this first one, they're being pulled together with a union. The union means the marriage of these two things. So everything you see shaded in each picture, imagine superimposing the two on top of each other. They're getting married, everything is coming. So everything that is shaded should be shaded in this final answer. So it's everything on the outside. But then also that little piece in the middle. While this first picture doesn't have the overlap shaded in, the second one does. And in the union, it's everything from both. So if this is what you were looking for, A complement, union B, this is where you would shade your answer or pull your answers from. Compared to these two same ideas leading to an intersection, if the two are intersecting, then it's only where they overlap. So again, visualize superimposing the two pictures on top of each other. Where do they have shading in common? It's definitely not on the outside of the circle, and it's definitely not in the overlap because the first picture doesn't have that, but they do have in common the shading in the part that is only B. So in this case, this is where you would pull the answer from. If these two are pulled together with an intersection, then it's only where the two overlap, and in this case they overlap in the part that is just B. So keep that in mind moving forward. Union intersection isn't always simply those two specific locations. It's the idea that the union is the marriage of the two and the intersection is where they overlap. All right, so to give you a quick summary, we looked at the complement, the union, and the intersection and started to really get an idea of what Venn diagrams look like. Complement is the idea of it being the opposite, so we could have a set and then we could have not that set, or we could have the complement the opposite of any number of things, so start with the original and then take the opposite. The union is the marriage of those two things coming together, so everything from both would come in a union. And then the intersection is where they overlap, so only with the two ideas have in common. So you saw those kind of visually represented, putting elements inside, and we'll continue on moving forward with 3 sets after this. I'll see you soon for another video.